Our blog has 146 posts across the past 5 years, and I believe we've put out lots of effort so that we can teach you lots of stuff. But we face one issue, and the issue is that readers cannot find next blog posts. Let's say, for example, somebody's interested in reading about saving Lambda costs. So we could go into the search and say Lambda, and there we can see different blog posts, and one, for example, is 5 tips to reduce your Lambda costs. And together with saving Lambda costs, the reader could also be interested in more. But finding this new blog post is not easy. And this is why I've built related posts. At the end of every blog post, you can now see a blog like that. And in here, we have a trained AI which looks for similar blog posts. In that case, for example, an AWS Lambda pricing guide, an AWS cost optimization guide in general, or about render, maybe an alternative to AWS. And in this video, I want to show how you can build this with native AWS services, with AWS Bedrock, and with the newly launched AWS S3 vectors. So let's dive into that. Hey, if you're new here, I'm Sandro, and I'm building AWS solutions for the past 6 years. I've built applications that millions of users have used in a serverless fashion and in a very cost-optimized fashion. And I think I started the same way as most of you did. I did a certification, I did my developer associate and my solution architect associate, and thought I can build after that on AWS, but turns out I can't, because it is much harder and a little bit different than the certifications tell you. And I want to share my learnings with you how to actually build real-world AWS. So in this video, I want to walk you through the whole architecture of how we've built our related post sections, beginning from how a blog post looks like, how we upload the blog post to S3, then training our vector indices on that, also diving a bit into what a vector index actually is and how similarities are calculated, and then going into Bedrock, connecting the whole thing with our knowledge base, querying the knowledge base, and then saving it at build time for every blog post, that we can actually show it without having many costs and in a statically fast and performant way. And by the end, you will have everything to get started and build that yourself. The architecture is pretty simple because we basically just use 2 services. First of all, we use Amazon Bedrock. Amazon Bedrock is the major AWS AI service out there. You can connect to your models through Amazon Bedrock, but you can also build things like a knowledge base. And a knowledge base is what we're using here. But the part I'm more interested about or more excited about is the S3 vector bucket. Because one of the recent launches from AWS was S3 vectors. And vectors isn't a new thing. I will show you what vectors are in a second. But the interesting part is that we now have a serverless and cloud native way with S3's capabilities on top to build vector indices. And then the third part is also S3, but this is actually just our blob storage, our object storage. So we have an S3 bucket which holds all of our content. But if I'm talking about our content, I mean our blog here. And our blog is based on markdown files. So you can see that we have some common patterns in our blog posts. Of course, we have a cover image, we have a title, we have an author, a date, and some. Let's see that in code. We use Markdown, which is a markup language, which you probably know from creating GitHub issues or just writing a README in GitHub. And what we use is we have a so-called front matter. And this front matter holds several key values. For example, we have a title, we have an SEO title, and so on and so forth. The basis of everything is our front matter and additionally the actual content of our blog post. So the first thing we now need to do once we have all of our content, we need to upload it to a normal S3 bucket. I will now do this with you step by step together. In S3, we go into create bucket. We create a new bucket, just a general purpose bucket. I just call it Sandro Content AWS Fundamentals. I keep all of my default settings and create the bucket and hope the name is not taken yet. Looks good. And there we are. This is our bucket. What we are doing now is we want to process and upload this content into an S3 bucket. In here, I have the front matter. So this is an example of the front matter. We process all attributes and then we upload it to an S3 bucket. All of the files we actually have. And we uploaded content and set metadata onto the S3 bucket objects. We do this manually once. So I selected the actual blog post here this video is about, building related posts with Bedrock Knowledge Base and S3 vectors. But I'm not uploading it yet because I want to add some properties. I don't care about the storage class or stuff like here. I care about metadata. And in metadata, you can typically say system defined, but there you need some predefined key, so you can only choose them. So I care about user defined, and they always start with x-amazon-meta. So, and now I can add some metadata to it. Why are we doing this? Because later on in the knowledge base, we could actually filter on that. If you want to query the knowledge base more granular, we could filter, for example, on this service. So one thing I will add is the service. In that case, this is about S3, so I would simply say S3. And we could continue on that and add more stuff, but I think for the purpose of showing it, you understand that. So we now upload this blog post. And now it's uploaded. Next, I'm running a script to upload all of my content into this S3 bucket. What the script is doing is, it is simply going through all of our blog posts, which again are locally markdown files, and then processes them, validates that some data is available in the front matter, like the title, the slug, and so on. And then we upload them automatically to S3 because it's much faster, of course, instead of doing it manually and attaching all of that manually. For that, I have a script called related posts, upload. Let's execute that. And now we can see in which stage we are, and we can see that the upload is starting. We can also see that one of two files, for example, have some errors here, but we're going to ignore them because we still have 140 posts uploaded. So you can see we have 4 failed uploads, just 2 MB. It took 12 seconds into my new bucket. Let's have a look in this bucket and reload. And we can see all of our nice blog posts in here. If you now look into the metadata of this post, for example, easy cross-account aggregation of log metrics, we can see that we have user-defined metadata like a cover, like the date published, an SEO description, which is very interesting for our knowledge base, then the service, which is super interesting, and some tags and some more stuff. So that's already pretty cool. Step 1 is done. Next, let's go into Bedrock. Bedrock is AWS's AI service. And here we can create so-called knowledge bases. So we want one knowledge base based on our content. So you can see that I have some knowledge bases already, but I want to create a new one, and I want to create a knowledge base with vector store. And in that case, I call it again Sandro, AWS Fundamentals KB for knowledge base. And we can see that we have different data source types here. You can use S3, what we actually want, but what you can also use, what I really am hyped about, is you can create a web crawler. So a crawler which always goes into the web and crawls some pages, for example. You can have a custom data source. You can have Confluence, Salesforce, or SharePoint. So you can even have like third parties integrated as a data source. But I want S3, so I go ahead with S3. I do not need a tag, and I create the source, the role automatically. But what I want and what I think is super important is I want log deliveries. Please set this up, because once you start syncing all of your stuff, you will have errors and you need to understand them and you need logs for them. To be honest, I'm not sure why this is not a default value, but let's simply say we want to do it in Amazon CloudWatch. So we just keep the destination log group. We click on next. And now it is actually also creating the data source. So we want to have it in this AWS account. We also call it Sandro AWS Fundamentals Vector. And now the interesting part is the parsing strategy. And to be honest, this is also where things can get differently complicated, because you can parse your data in different strategies. But I don't want to go into that. I don't want to give you a machine learning basic class here. I will go into vectors in a second, but for now, what I'm only interested in is that it is an initial MVP implementation and that it's fast and cheap. So we go with the Amazon Bedrock default parser. It also says best if only parsing text, and we're only parsing text, so I'm not interested in parsing all of the images and architecture diagrams I have in the blog post. I just want to parse text, so let's execute that. And then we have a chunking strategy. And I think chunking strategy is also very interesting for that, because what we are doing actually here is we create our knowledge base. Our knowledge base is trained on our content bucket, and the content bucket is where all our blog posts are in. And what we are doing, so the process looks like that: we chunk our documents into different chunks because we embed our documents into a numerical representation. And for that, we cannot use the whole document because, of course, blog posts can be very, very long. So we need to chunk it in different chunks. Then we call a machine learning model for embedding it. So we get some numerical representation, and then we store that in a vector index. But why are we doing this? I said the word vector a lot now, but what actually is a vector in terms of this context? To understand this, I have created some very basic diagrams just to get an idea of how vectors look like. And if you imagine the similarity of services here, so not just of posts, but let's say similarity of services, then everybody of us knows, if I tell you or if I ask you, is DynamoDB more similar to DocumentDB or to EC2 autoscaling? Then you will probably say, okay, no, it's like more similar to DocumentDB because it's also a database. Similar to if I ask you, is Lambda more similar to EC2 or to DynamoDB? Then you would also say it is more similar to EC2, right? And this is the whole idea of our vector index, because we want to see the difference in a kind of numerical representation of how far away is Lambda to DynamoDB and how far away is Lambda to EC2. But we're not caring about services here. We want to know this for blog posts. So I've shown the whole thing with some example blog posts we've actually created. So we have a blog post about pricing from our database, DynamoDB streams, and some introduction to Aurora. And then we have a blog post about Lambda cold starts and something about autoscaling groups with ECS cluster provider. And we can again see that these two are more similar than DSQL and Lambda. And to showcase this even further is that I've actually drawn in the vectors. So a vector is here simply a distance from one post to another with some, let's say, with some calculation metric. Typically you use Euclidean distance or cosine distance. So we can also say Euclidean distance or cosine distance. I won't show you the math here. I have it slightly in the blog post, but this is the typical thing we use, what we also use in our implementation. And then we can, for example, see that if we want to know what is similar to D-SQL pricing, we see that it's like 0.07, whatever unit you define it is DynamoDB streams more similar compared to Lambda cold starts, which is farther away. And having this on this XY axis is how we want to think about it, because this gives us, or this enables us to actually see what is related to each other. For me, the important part is I'm not doing a math class here. I'm also not a math pro here, but for me, the important part is you need to understand the lower the number, the closer they are together, and the better related is the content. I also show this in the blog post again, that I show you that we have some numbers on our XY axis here. For example, I simply said here, this is 1, 1, and 7. So you can like have this calculated here in your XY axis. And this is how you can then calculate your Euclidean distance or cosine distance. Exactly the same thing I have just shown you. So let's head back to our knowledge base creation wizard. So we're still in here, we use the default parser, and now we need to talk about chunking. Because blog posts are really big, we need to chunk them into different chunks. And here are different methodologies to do that. We can use some default chunking and say, okay, we use 300 tokens in size. Or we can use some fixed size chunking, we can use some hierarchical chunking, and even more. I use fixed size chunking and I simply say, let's use 2000 tokens, 2000 tokens, because we want to keep our chunks rather big. And to be honest here, we want to keep it rather simple. You could also use hierarchical chunking, which makes sense because a blog post has a hierarchy. We have a heading 1, a heading 2. We have stuff that belongs together. But in the end, what is important for us is to keep it simple for now, to have an MVP. But this is one part you need to keep in mind where you can improve a lot. We say the overlap is 10% for now. Again, please improve on that, but for now we just keep our default values and then we click next. And of course we need to define our bucket where our stuff is in. And this is the one I have created, Sandro Content AWS Fundamentals. So I choose this bucket and then I can click on next. And now we need to select an embeddings model. And again, here are different models available. We want to keep it simple. We use a text model. We simply use title text embeddings v2. Apply this model again. If you want to optimize on that, the model selection could also be important here. I only have those activated for now. And we want to create a new vector store. The vector store will be S3. And we want to create a new one. So this is done automatically. So now we can review everything again. And then we can create the knowledge base. Now our knowledge base was successfully created. It also already says it's available, but we need to check if it already synced something. And I don't think it did, because if you look, last sync time was never, so it never synced so far. Before you go in there and click on sync now, what I would do is I would open up CloudWatch, that we can watch it and have some live tail going on and see what actually happens. Turns out I haven't edited it properly, so if you are not sure where it is, you need to click on your edit page, see log delivery, and here you can find your CloudWatch log group. Again, AWS UX is not always the most straightforward one. And then we can go into this log group, application logs, and we can create a tail. And what tail is doing, it simply streams all of the logs in here. I love that feature from CloudWatch, by the way. And then we say we start a sync. And what is now happening, now everything comes into place. We first of all ingest our content markdown into our parser. So the text parser is parsing the text. Then we chunk it into 2000 chunks. So we have 2000 chunks. And then we embed this chunk into a vector index, and then we save it in the vector index. And here in the logs, we can simply see our events. So we can see our ingest job ID and so on and so forth. I don't expect that something important comes up here, but we see that it is running. If we go to the knowledge base, we should also see that the data source is at the moment syncing, and actually it is already done. So everything is indexed. As you can see here, we can see our objects, and then we see the status indexed. In our S3 vector itself, we won't see much, because the vector, you can call it via an API and actually get the vector values. But what is much more interesting for us now is that we actually get it via the knowledge base. So what we're doing, we go to our knowledge base and we can say test knowledge base. And in the test knowledge base, we can say, let's set it on retrieval only. So we have here something to put text in. We have a preview, and then we have some options. We can combine it with another model. So with another LLM, which passes this data into the LLM, but I'm only interested in retrieval. We can also define how many chunks we want to have returned, search type, filters, guardrails, and so on, but we are only interested in testing it out now. So what I expect to happen is I add something in here and it returns me the chunks. So important, we are talking still about the chunks because the chunks are embedded. It returns the chunks of the blog posts which are related to each other. So again, if I say Lambda, I expect that I get some chunks from Lambda blog posts. So now it calls the knowledge base and the knowledge base returns with some chunks. For example, I can see it will also slow down your function deployments from a few seconds to a few minutes. Limitation, blah, 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 and so on. Then we see some front matters, for example, introduction to Lambda, tips to save Lambda costs, and so on. The cool thing is we can now show the details. Let's make this a bit smaller and see the actual chunks and the actual score, how far away the term Lambda is from this chunk. And here we see the source chunk. Of course, this is markdown, so you can see this is bold, this is a third heading. But what we want in the end is a JSON file like that. So for each blog post we want to have 3 related posts. And for example, for the blog post, a comprehensive guide to AWS compute services, pretty general one, we want to see the most related ones. Sounds a bit like we don't have too many, but here we have the blog post, how we build a social stats dashboard, then introduction to Lambda, which is of course similar to compute, and then something about Lambda pricing. And I also want to save the similarities. And then I want to display this in my Next.js frontend application. And how we're doing this is here described in the part about generate related posts. Because first of all, this is a local script which runs once in deploy time if a new blog post is in there. Because what I don't want is we have lots of visitors on our blog. And what we could do or could have done is that each time a visitor comes on our blog, we call the knowledge base and then pay for each API call. But we have over 1,000 or 2,000 visitors a day on our blog. So this would be lots of costs for something that doesn't change a lot, because we mostly publish a blog post once a week. Doesn't make sense to pay for that every time. So what I decided to do is have this hard-coded JSON file and regenerate this on every deployment again. And the script is working like that. You get the local blog post and all of the front matter. So the service, the title, the description, and so on. So this is the markdown file which flows into the script. And then we build a query. And the query is very important, and this is a crucial part to improve after some time. But we've built a pretty simple query here by saying, give me similar blog posts, again, chunks, with the title, the service, description, and tags. I also tried it out with passing in some more descriptions, for example, the SEO description. But adding more features here makes sense. But again, we want to build an MVP fast, so this is it. We just go with a default query, and then we call the knowledge base. So that means we call Bedrock. Bedrock is here. So we have our knowledge base. Again, the knowledge base is based on the vector bucket, and the vector bucket is based on the chunks. So we get chunks returned. What I'm doing then, and this is because our model is not improved that lot, and you will not always find related posts. And I still want to show my user some relevant new posts. So I always want to have 3 posts that I can show him. So no matter what, if the AI can find one or not. So what I'm doing then is I check, do I have at least 3 results? If yes, I save them in the JSON and I'm done. If no, what I'm doing is I use random posts from the same service. Because if I'm talking about Lambda here, so if this is a blog post about Lambda, the chance is high that some other post about Lambda is related. This is my generate related post script. I don't even want to get too much into detail here, but I think what is interesting is to actually see how the query is created. So we have a function called find related posts for blog, and then we have query parts. And this is where we put in the title, the service, if it exists, and the SEO description. And then we get the top 3 tags if available, because we stopped using tags at some point. And then we use the query, and this is how we query the knowledge base. So we query our knowledge base with the retrieve command API. We send it to Bedrock, and then we wait for our response. So I execute the script related posts generate. I already added the correct knowledge base ID here. It loads it all blog posts, so we see 144 blog posts. And for each blog post, it now calls the API on our knowledge base and checks out if they are related posts. For example, here we have 3 related, and so on and so forth. We do that in a batch size of 30 because Bedrock still has quite tight rate limits. So it is important that we don't come over the limits to not get too many errors. And then the whole thing runs. It's already done. You see for 144 blog posts, it's super fast. And we can see that post processed 144, we found 432 relations and we saved them here. So this is the updated file. Of course, it looks similar now. We can also look into the results I just mentioned, where we have some more results where we say, okay, how many posts have 3 related posts? Here we can see that all of them have 3 related posts. We don't need any fallbacks, which is quite nice. And this is how we actually did that. Now, I'm a full stack developer, so what I'm doing is I've built a React component called related posts. Of course, I did the whole thing with Claude and it looks pretty cool. So what it is doing here in build time, it reads in the JSON file and shows all of these related posts. And this is only happening once while we deploy it. And this brings us back here to our vector search, to our related posts. Of course, most of that is just UI because it looks nice in this tacky way. It is not an actual CLI here, but this is how we could query it. And this is how we come for our related posts. Some gotchas I found is, of course, now we found 3 results for all of our blog posts, but this is also because I tested the queries a bit, but there are many things we can improve. For example, we can use better chunking. We can embed post summaries. So for example, we could put even an LLM one step before and say, give me a summary with the maximum of this size of this blog post. And this is how we could build the query as well. Then we could filter on metadata. We saw that we have metadata within our S3 data. So we could filter on that and say, okay, I'm only interested in the compute category. If we say we have, I don't know, a post about Lambda pricing again, and we say I'm only interested to show other posts in the categories of Lambda, ECS and EC2. So we could use that. And then in the end, it's all about better query engineering. What I showed you is that we use a pretty simple query with embedding the title, the SEO description if available, and some tags. But this can be done even better. And all of that, in my perspective, comes down to feature engineering in machine learning, which is the classical thing which improves the results much better compared to simply making a better model, using another transformer model or stuff like that. We really want to work on the features. But in the end, we care about the user's perspective. We care about our readers, and they have a benefit if we publish things like that fast. This is why we did this really fast, and this is why we're still improving on that. But to be honest, even with showing random articles which are related in the same category or in the same service is already a huge win for the user. You keep them on your site and they can read about it and they maybe learn something more. This is it. I hope you enjoyed it. If you want to learn more about building full stack and hands-on AWS stuff, especially AWS for the real world with skipping all of the certification stuff, make sure to check out the newsletter. We also have different infographics. We don't have a Bedrock infographic yet. It's coming soon. But at the moment, check out the infographic about CloudWatch and about S3, which are also used in almost every AWS application out there. I hope I could teach you something, have fun, and go out and build.